particular ultrasonic says 8 cycles of particular. So you have a counter, you send high, low, 8 times counter, stop. That's all. That means that your signal is 8 cycles of particular hertz that is generated and it is left. You see the next, I think, so particular is generated. Yes, this is the slide, and it is going from this emitter, and this is the transmitter, and this is the receiver, and the T and R will be there. The transmitter goes there, ultrasonic waves reach the target, and then they will reflect there. So you see they travel a distance of S and returns the distance of S, 2S distance, and they take a time T and T, 2T. So now this has to be calculated, and you see the return signal will be checked now. Whether it is having the same 8 cycles and 40 kilometers. Duration must be 12.5 microseconds, and it should be only 8 counts. If these two matches, yes, that is taken care of by the microcontroller in the what we call the ultrasonic sensor module, and if it matches, then you will see that the echo signal is detected, and the moment you send the signal, you have a start pulse, echo signal. This is the gating pulse which goes high. So when you are about to send the data, the gating pulse goes high, and it remains high as long as the echo comes and it is received. When the echo comes, gating pulse goes down. So this is the signal that we generate, and we give it to AND gate. What are the input of the AND gate is connected to the echo signal. What is called this? Okay, AND gate. One of the input is gating pulse. The second input is 1 millisecond clock pulse. So you see, every time 1 millisecond pulse goes in, the output also will be changing its state, high state to low state. But how long? As long as the gating pulse is high. So that gating pulse being high will be decided by the echo. So as soon as the echo signal is received, the gating pulse goes down. So now we know that the gating pulse is high when the sound waves travel a distance of 2s in a time of 2t, and during which time the now count in the clock is going to be n. So n milliseconds. All these things are now calculated in the next. The ultrasonic sensor emits a short 4 particulars cluster 8 cycles. This travels through air at 330 meters per second. Hits an object, comes, bounces back to the sensor. Sensor provides an output pulse to the host that will terminate when the echo is detected. Hence, the width of this pulse corresponds to twice the distance to the target. You come to the equation. See that the time difference is 2t between the transmission of the ultrasonic wave and reception of the reflected wave as echo is proportional to n, the count n stored in the counter. From the speed of the sound wave, we can calculate the distance of the obstacle from a sensor. Sound travels at 330 meters per second, which is equivalent to 29.6 centimeters in 1 millisecond. So it travels 29.6 centimeters in 1 millisecond. We have 2s is proportional to 2t, which is equivalent to n number of millisecond pulses. So the millisecond pulse is n multiplied by, see that? So s is t by 2, which is n by 2. So the sound travels 29.6 centimeters in 1 millisecond. So in this time, it travels 29.6 multiplied by n by 2. So you see, s is equal to n by 2 into 29.6 centimeters. This is the distance in centimeters. So this is how we do the calculation. The ultrasonic sensor is able to judge the distance. Because we can say use for distance measurement. And we have used this ultrasonic assisted vision pad. See that we can mounted it on a stick and given it to the blind people, and when they keep the stick in front, and if it is above 1 foot or 5 feet, 5 feet you get a strong 1 kilohertz. But if it goes low, it is reversing. So, and it is 1 foot distance is only 1 foot. Depending on the distance, you get n value. So you can have 1 foot, n is 100. If the value of n is less than 100, immediately you can get a high frequency sound, and a person will stop, and then you will put the stick on the right side and then the left side. When you put it on the right side, if the distance is long enough, you will get a very low frequency. If you put it on the left side, if it is very close, say 5 feet or 3 feet, it gets a frequency. So you know, you can judge, oh, this side you've got more space, so you will turn right and go. And also, we have put one, JBS college student from here, she said, sir, we must have water along inside. So we have got two probes connected to the bottom of the rod, so that when he places it, it senses the water, the sluggish mud and all that. So that gives a signal, the different sound, and the person will know, oh, it's sluggish water, water is there. So he will keep his leg very slowly and will be careful. So he will be able to help people, and this way, ultrasonic sensor we have used it. And this is the next thing. We have, oh, motor DC motor drive. So there are one we can write the LEDs, and another we can activate the buzzer for sound, and for robots we have to activate the motor. DC motors can be controlled by a special chip called L293D. Okay, it will control two motors against the single chip. It is nothing but Darlington path. We have got Darlington path for current amplification. So when you give one volt to that, then the current will be magnified so that it can drive the motor. If you, just like that, you connect, it cannot give that much current, but you have to send it through the L293D chip IC DC motor driver. Driver means it will increase the current. How? Using Darlington path. So that way we will be able to rotate. And the configuration, you see, this is motor M1 and M2. There are two motors which are available, and here only one motor I have connected. Input, see that if the C1, C2, I think I should check, enable pin. C1 is 1 and C2 is 0. Two the control frequency of the dip. 1, 0 means it will rotate clockwise. 1, 0 turn right or turn left, and how that information is communicated to the robocar. So for that, we use this coding. Key 1 will generate 001, key 2 when I press will generate 001. Three types of binary data we are able to generate, and these digital data are fed to encoder chip HT12E, and these encoder chips are connected with the RF generator. Because I told you it is RF control, which is 434 kilohertz. So 434 megahertz, and 434 megahertz frequency is coupled with the digital data, and through ASC control. ASC means amplitude shift keying. Digital data can be transmitted. Means if it is 0, the output of the oscillations will be 0.5 volt, whereas if it is logic 1, the height amplitude of the oscillations will be 4.5 volt. So we can vary the alteration. If it is 0, we'll have 0.5, 0.5, 0.5, and 1 means 4.5. So this is the information which will be transmitted in frequency of 4 with the carrier frequency of 434 megahertz. So this is how 12E, HT12E will generate it mixed with 434 megahertz frequency to generate as modulated signal and transmitted as electromagnetic waves into space. So this will be the transmitter say in your switch you will have it. You can switch can be about 200 meters from the robo. So that is the range of your 434 megahertz oscillator, and the digital data commands from keypad is received by all of receiver section, and it is decoded by, so encoded data is transmitted. Now it has to be decoded. So 12D, HT12D will be the decoder chip which will remove the RF frequency. Again, it will have a local oscillator 434 megahertz crystal oscillator. Along with that, this digital data, ASC data will come, and it will decode the data 0001 or 0010 out of the 5. One of the data will be decoded and it will be put in one of the registers of the. So you see that depending on that, two sets of commands are given. If it is 00, we know it has to go forward. So you should know what type of output conditions that we have to give. Means make both the motors go forward. So you give C1, C2, C1 prime, C2 prime, both 0, 1, 0, 1, 0. That's a 4 bits of data will become high. So you make 4 bits digital pins, high, low, like that. Connected to C1, C1 prime, C1, C2, C1, C2, and C1 prime, C2 prime. That's all. So that means you are communicating the data to the actual activity, L293D, and L293D will control the motors to rotate clockwise, and the rover will move forward. See that? The two rear wheels of the robo are connected to the two DC motors, which take the signal from the motor driver. The third steel ball clockwise 0, 1, anti-clockwise 0, 1, therefore the robot moves backward. 0, 1, 1, you want to turn right, that means your right side must stop, and left side must go forward, so 1, 0. So it clockwise, and then it is stopping, it turns right. Then the robot has to turn left, reverse. and 10 turns left. All one, it stops. So the RF receiver attached to the receiver takes command from the transmitter remotely. Each time a key is pressed on the remote command, the remote is activated to perform one of the above 5 actions. Now comes touch keypad. We made our own keys connected to RF transmitter receiver module, and we control manually. Here also we are going to control manually. This is also manual control, but wireless. We use our mobile phone app. So we use the Android app defining touch keypad for push keys. Use select any keys and then that user section of the mobile phone. 2.4 gigahertz and data speed of 48,400 bits per second. Data speed means the time taken between one bit and another bit. So in 1 second, 48,400 bits can be transmitted. So that's data speed is different, and the frequency of the data is 2.4 gigahertz. So that it can travel. Okay, so it moves, and the electromagnetic waves are sent via antenna and goes to the Bluetooth monitor IC HC05, which is attached to the robo. So the robo now has HC05 Bluetooth monitor control IC. What for? Why should we have it? There is no decoder here. HC05 receives the signal and at the rate of 48,400 bits per second, converts it to 9,600 bits per second. So the role of HC05 Bluetooth monitor IC will be to change the data speed from 48,400 to 9,000 baud rate, and that will be acceptable for game. So in the output of AC05, TX and RX lines will be connected to the TX using ultrasonic waves, we can have robots, obstacle avoiding robot. I have explained these things. Okay. 1 foot distance, 100 less than. This is security control using biometric fingerprint sensor. So RFID non-touching, whereas here touch. So use your fingerprint for your own control, your jewel box and other things. If you want to keep it safe, use your fingerprint. And then fingerprint sensor AS 608 can record some 600. So your class, about 30 people, QMC principal and HOD has asked me to develop this for attendance. Every week, automatically, end of the class, so you have the records at that time. Like that, we can create a record, and at the end of the day, the information will be transferred to this form. So that project we are planning to do. It is possible with the fingerprint sensor. It's AS608 600 data. It's only 30. Okay, we can do it. So this idea is you put your finger, and then some of the important junctions points are noted down, and it is the image. Actually, it's the image. Image is recorded, and 600 images are can be recorded there. And when a valid person comes in and places the finger, yes, it detects, matches with that, and then you say access granted, and we will make the servo motor rotate clockwise so that the door opens the latch. So your permission is granted. If it doesn't match, permission denied, and the red light will burn, and alarm can be given so that you can also receive some alert messages. So this is how this project we have done it. Biometric fingerprint. Yes. I have suggested a few projects because we are all student group. You can select a few projects from this, and some of the projects we are displaying it today. This is the list of projects we are displaying it today. Sensor-enabled embedded projects. You can see after the lunch, you can have a look at it. LPG leak detector, saline water drip solution using LDR, soil irrigation water flow monitor using soil moisture sensor, auto open close using the dustbin. You are asking, you must have an awareness that the dustbin is over. Yes, you must get a signal so that somebody will come and take it. Otherwise, it will overflow and cause a lot of problems. Drunken driving detector. This is we are using a Node MCU chip, IoT portal chip, which will be connected to Wi-Fi. So it can connect it directly to the suppose the police constable stops you at about 12 o'clock when you are driving, says ask you to blow the alcohol detector will detect. If it is below the permitted level, you will say hello, you will say go. But if it is slightly more, okay, more than the permitted level, then you will say yes, you have to pay the fine. And it is also not supposed to allow you to drive the car. The driver should change, and he must collect the fine. But what happens normally, instead of collecting the fine or recording the data, he will let you go after getting the money, which can be now automatically checked. Because the moment the reading is above 500, the information will say such a time somebody has come and is above the permitted level. So one case is recorded. Like that, 4 cases are recorded. And if he has done some 20 cases on that night and he has reported only 2 cases, the record is for 4 cases, then you say you cheated the government and you are down the person. So that way we have changed the alcohol detector. And this one important project which we have done, we have displayed, and secure door open close, remote control door open close, Android mobile, which I have told you, you can see that. and line following robo, automatic collision avoiding robo. When one car is moving, the other car is following. You keep your ultrasonic in your front bumper, and the front car applies brake suddenly. Your car should stop. Reduce the, but if you are a little careless, within that time you will go and bang on the front vehicle. So here the machinist will take care of. If the distance is about 10 feet, yes, you will be given maximum speed. The speed control is there. But when the distance comes to 5, the speed control reduces automatically to 40 kilometers. And if the distance is less than 1 foot, it reduces to 0 kilometers speed. So automatically you won't bang, you will stop. At the same time, the vehicle coming at the back should not bang on you. So we have given lights. When you are going maximum speed, you got a green light at the back. And if you are going at 50% speed, you get yellow light indication, and the way to stop immediately, abruptly, red light will come. So that the person at the back. So these things I have depicted in that. You see that the urban tracks, each one was having, so one car, another car, they will brake because they are having the auto collision avoiding. In train also, for 1 kilometer distance, we can stop. That is a Kawachi, which the central government is not installing in all the trains. But if you install it in your car, you can avoid colliding with the previous things. So that is the thing. Collision avoiding robo car using across the lane. Come back after lunch. Thank you.